looking at is a liquid, it may be easier just to measure the volume. And if that's the case, we might look at density. Density is mass divided by volume. And so if I know density and or volume and or mass, I can solve for the other. Glycerin is a sticky, thick liquid at room temperature. 1.26 grams per milliliter is the density. What volume of this liquid, if I poured this thick glycerin into a cup or a measuring beaker or a cylinder, what volume would it require to allow us to get 55.5 moles? I just made that number up. I did not make this number up. That is the measured density of glycerin. So this number could be anything. If I just require a certain number of moles of this glycerin as a reactant in a chemical reaction, say for example. Well, here I changed moles to grams with the molar mass, and I'm saying 55.5 moles of glycerin is equal to 5,110 grams of glycerin. All right, so what? Well, let me use this density as a conversion factor. Let me say 1.26 grams per milliliter. I just flip-flopped it upside down. Put the grams on the bottom so they cancel. 5110 divided by 1.26. Grams cancel, milliliters. Wow, that's a little more than 4 liters. That's about a gallon of glycerin to get 55 moles of glycerin. And one other thing. This is ending up to be a quite lengthy clip. I apologize. For gases, they're so fluffy. Let me remind you how we get the moles in a particular gas. For a gas, we need to use PV equals nRT. N is the number of moles of particles. V is the volume in liters. P is the pressure, and atmosphere is the pressure the gas is experiencing. T is the Kelvin temperature, and R is the gas constant in these units, which helps me remember temperatures in Kelvin, number of particles in moles, volume in liters, pressure in atmospheres. And again, hopefully in your first general chemistry course you have seen this, so it's not a total mystery, but perhaps it's been a while. So to review, let me use this. I could solve this for N if I know the pressure, the volume, R is the constant, T the Kelvin temperature. I can make up any kind of silly example I wanted to, and I did. 4 liters of a gas sample. And notice this is not specific to the gas. So this is a physical property of gases that you can use PV equals nRT if they're behaving ideally to calculate or get a very good estimate on the number of particles regardless of what the type of gas is. Could be oxygen, nitrogen, carbon dioxide, sulfur hexafluoride is a little bit big, but the larger the gas is, the less ideally it behaves. 2.1 atmospheres of pressure, 25 Celsius is the temperature, 4 liter volume. So how many moles of gas are in this container? PV equals nRT. So there's the pressure, there's the volume, there's the gas constant, and you'll notice and remember you have to change the Celsius temperature into Kelvin to make that cancel with that. And so 2.1 times 4 divided by 298 and also divided by 0.0281-ish comes out to 0.34 moles of gas. A physical way for measuring physical quantities for determining, counting the number of gas particles. And thanks for watching. See you in class.